So welcome to Step Restitution Center. So today's topic is similarities and congruence. So the first question we have is, so this is math, guys. So the areas of two similar cylinders are 64 centimeters squared and 32 centimeters squared, respectively. If the height of the larger cylinder is 30 centimeters, find the height of the smaller cylinder. So they've given us areas of two similar cylinders. So we have 64 centimeters squared to 36 centimeters squared there. So if the height of the larger cylinder is 30 centimeters, so we're finding the height of the smaller cylinder. So what we do here, we have to square root this since it's area. So first let's reduce this. So we can divide by with yeah, so guys, as we can see, we have a number that can go into both 64 and 36. So that is 4. So we aim by all means to try and reduce this. So if you see that there's a number that can go into both the figures we've been given, so try to reduce. So let's reduce here. So we can divide by 4 over 4 there. So 4 into 64, that's 16 meters squared, to 4 into 36, that's 9. So now we can square root since we know the square root of 9 and 16. So square root. So we are going to have 4 to 3. So we've reduced now. And they've said now the height of the larger cylinder is 30. So as you can see now, you compare the two numbers. Which one is bigger between the two? So it's this one, the 4. So that's where 30 will fall as well. So find the height of the smaller cylinder. So we don't know the height of the smaller cylinder. So that's x. Then you can cross multiply there. So 4 by x, that's 4x, is equal to 30 by 3. So let's do this. So over 4 over 4. So x is equal to 2 into 4, that's 2. Then 2 into 30, that's 15. Then 15 by 3, 45. So 45 over 2. So x is equal to 2 into 4, that's 2. And 2 into 5, that's 2. Then we're going to have a remainder of 1 over 2 centimeters. So we are done. Then the second question, the areas of the faces of cubes A and B are 9 centimeters squared and 25 centimeters respectively. Find the ratio of their volumes. So we have 9 centimeters squared to 25 centimeter squared. So is there a number that can go into both 9 and 25? So we don't have. So we'll go direct here. So let's square root first. Square root, square root. So the square root of 9 is 3. Then the square root of 25, that's 5. So the way it is, so if we want to find the ratio of their volumes, so we aim by all means to reduce this into its length. Then once it's into its length, that's when now we can find the ratio of their volume. So that's why I had square rooted here. So the square root, if we square root even the centimeter squared here, we are just getting centimeters. So that's why I had reduced so that I can have their original length. So now since we have their original length, now we can cube root. So cube root. So the cube root of 3, that's 27 centimeter cubed, to the cube root of 5, 125. So that's 125 centimeter cube. So you are done here. So since we have their volumes here, 27 centimeter cubes to 125 centimeter cube, so over centimeter cubic, and also this one, because we are finding the ratio. So centimeter cubic, centimeter cubic, centimeter cubic. So we're going to have 27 to 125. So that's the final answer. Then, so the next question, rectangle ABCD and DAEF are geometrically similar. So the rectangle ABCD, this one the big one, and DAEF, the smaller one. So given that AB is equal to 10 centimeters and AD is equal to 4 centimeters, calculate the area of rectangle DAEF. So DAEF. So what we'll do first, let's find the area of the large rectangle there. So area is given by L times B. So area is equal to 4 times 10. So area will be given by, so area is equal to 40 centimeter squared. So first we are done with the area. Then we've been given the ratio over their sides. So which is 10 to 4.
Depends for the bigger one, depends for smaller one.
So this is for the bigger one, 10. Then for the smaller one, it's the 4 there. So what we do, we can reduce this.
Do the sides.
Yeah, the sides, yes. So we reduce the sides over 2 over 2. So that will be 5 to 2. Yeah. So we have the ratio of their sides there. So since we want to find the area, so we turn this, the ratio of their sides, into area. So we square, square. So 5 squared, that's 25. 4 squared, that's, the 2 squared, that's 4. So 25 to 4. So we have the 40 for the bigger one. So 40 to x. So 25x is equal times. So 25 by x, that's 25x, is equal to 40 by 4. So this will be over 25 over 25. So you can reduce it here from here. So 5 into 25, that's 5. Then 5 into 40, that's 8. So 8 by 4, that's 32. So we can say 32 over 5. So 5 into 30, that's 6. 6 remainder 2. So we can just say, we can 2 over 5, or is equal to, or 6.4. So yeah, so this will be 6 to over 5 centimeter squared, since we are finding the area of the smaller rectangle. So the heights of two similar cylinders are 4 centimeters and 6 centimeters. If the volume of the smaller cylinder is 48 centimeter cubic, find the volume of the larger cylinder. So this is our question 5. So we've been given the ratio of their sides, so which is 4 centimeters to 6 centimeters. So let's reduce first the sides. So number that can go into both 4 and 6, that's 2, and over 2. So 2 into 4, that's 2, and 2 into 6, that's 3. Then now, since we are finding the volume of the larger cylinder, which is for the part which has a 3 there. Yeah, so we can cube first. Cube, yeah, over 3 over 3. So 2 to the power 3, that's 8. Then 3 to the power 3, that's 27. So now we can compare which one is larger between the two. So we can see it's the 27. And they've given us the volume of the smaller cylinder, which is 48. So the 48 comes here. Then 2x. And now multiply there. So 8 by x, that's 8x, is equal to 27 by 48. So over 8 over 8. So our x will be equal to, so 8 into 48, that's 6. Then 27 by 6, we're getting, so 27 by 6 here. So 6 by 7, that's 54, is it? Yeah. then 6 by 2, that's 12. Then 12 plus 5, that's 17. So 174. Oh, sorry guys, I made the mistake here. So let's do it again. So
Volume.
7 by 6, that's
162.
yeah. So 27 by 6, that's 162. So our volume will be 162 centimeter cubic. So the question 6, the ratio of the volumes of two similar solids is 64 to 27. So the surface area of the smaller solid is 180 centimeter squared. What is the surface area of the bigger solid? So they've given us the volume. So 64 to 27. That's the ratio of their volumes. So what we can do here, first we need to reduce the ratio of their volumes into their sides. So is there a number that can go into both 64 and 27?
No.
Don't have.
So
So
cube root.
we cube root. So the cube root of 64, that's 4, and the cube root of 27, that's 3. So is there a number that can go into 4 and 3? No. So now we square this, but since we are finding what is the surface area of the bigger solid, so we are finding the area of the bigger solid. So we square this, square, square. So 4 squared, that's 16 to 3 squared, that's 9. So surface area of the bigger solid. So between the two numbers, which one is bigger? So you can see it's 16. So that's where our x would be. Then 2, the surface area of the smaller solid, that's 180. So 9x, also you multiply there, so 9 by x, that's 9x is equal to 16 by 180. So over 9 over 9. So it's coming. So this and this goes. So
920.
9 into 18. So 9 into 9, that's 1. Then 9 into 18, that's 2. So 20 by 16, what are we getting? So we can multiply here. 16 by 20, as you can see, we have zeros, 0 there. 2 by 6, that's 12. 2 by 1, that's 2. Then plus 1, that's 3. So this will give us 320. So 320 centimeter squared. So that's the area of a bigger. So question 7. A cylinder with diameter 2 centimeters has a volume of 5 centimeter cubic. Find the volume of a similar cylinder with diameter 8 centimeter cubic. So what we do first, so they've given us the diameters. So 2 centimeter cubic, that's for one cylinder, and for the other one it's 8 centimeters. So what we do, we can reduce first, over 2 over 2. So we're going to have 1 to 4. Then since we're finding the ratio of their volumes, so now we'll cube. So 1 to the power 3, that's 1. Then 4 to the power 3, that's 64. So we've turned it into their ratio of their volumes. So now, since they told us that a cylinder with diameter 2 centimeters has a volume of 5 centimeters, so the 5 comes here. Then 2, so we don't know the one for the 8. So it's equal to x. So this will be x is equal to 64 by 5. So x is equal to, so we can multiply 64 by 5. So it also give us a 320. So our x is 320 centimeter cubic. So that's the volume of the similar cylinder. Then the ratio of heights of two containers that are geometrically similar is 2 to 3. If the surface area of the smaller container is 80 centimeter cube squared, find the surface area of the larger container. So what we can do, the number that can go into 2 and 3. So there's no number. So that's just 1. So we have the same thing. So we can square these two. So 2 squared to 3 squared. So 2 to the power 2, that's 4. And 3 to the power 2, that's 9. So they've told that if the surface area of the smaller container is 80. So between the two numbers, which one is smaller? So 80 is smaller. So to x. So we're going to have, so we multiply. So 4x is equal to 80 by 9 over 4 over 4. So x is equal to, that's 1, then that's 2. So x is equal to 20 by 9. So x will be equal to 180. So that's 180 centimeters squared. So we're done. So question 10. The ratio of the surface areas of two cubes is 16 to 25. What is the volume of the smaller cube if the volume of the bigger cube is 500 centimeter cubic? So we have 16 to 25. That's the surface area of two cubes. So this is, what's this? The ratio of their sides. So what we can do first, so this is the ratio of their areas. So since we are finding the ratio of their volumes, so what we can do first, we can look for a number that can go into 16 and 25, which we don't have, so we can square root from here. So the square root of 16, that's 4, and the square root of 25, that's 5. So is there a number that can go into 4 and 5? So that's 1, and we'll have the same thing. So we are now finding what is the volume of the smaller cube. So between the two numbers, which one is smaller? So it's 4. So that's where our x will be there. Because I've said if the volume of the bigger cube is 500, so I have 500 there. So 5 by x. Oh yeah. So sorry guys, I forgot to cube these two numbers. So cube. So 4 to the power 3, that's 64. And 5 to the power 3, that's 125. And x to 500. This makes more sense now. So 125x is equal to 64 by 500. Yeah. So over 125 over 125. So x is equal to, so if we multiply this by this, when we divide by 125, we're getting, so 125 into 500, 1, so we're getting a 4 there, then 64 by 4. So x is equal to 256. And we can put our centimeter. Thank you very much for staying with us. This was fun. I enjoyed. Hope you guys also enjoyed. So guys, don't forget to share the video, yeah, to your friends as well. Thank you.